Hello. So today we're going to be looking at using law of cosines when given three sides to find angles. So we have a triangle here with sides 2, 3, and 4. And we want to find out what are the angles within this triangle. So let's find this angle first. We'll call that X. And we can call this one A, and we can call this one B. Just in case we want to find the others after the fact. We'll probably just find just two for this video. So that leaves you the third one to find on your own. So how do we find the angle? Well, law of cosines involves all three sides in one of the angles. In this case, we know all three sides. So we can use it to find that other angle. So let's find X first. Well, by the law of cosines, X would be opposite of the side 4. So law of cosines, we would start off with 4 squared being equal to the two sides that make X. So 2 squared plus 3 squared minus 2 times those two sides. So 2 times 3 cosine of, in this case, X, because that's the angle we're looking for. So again, let's set that up by the law of cosines. X is opposite of the side 4, so we'll have 4 squared equal to the other two sides. So 2 squared plus 3 squared minus 2 times 3 cosine of X. And okay, so that's how you would set up the law of cosines. From here, we can solve to get X by itself. Well, let's see how we do that. Well, in order to get cosine of X by itself, first and foremost, a lot of times it'll be easier for most people to simplify things. So let's do that in this case. But as you can see, this is being multiplied times cosine of X. And we know from solving complex algebraic equations that we would get rid of, or we would move to the other side, the things that are being added and subtracted first. So these two pieces would get moved to the other side first, and then we would divide by what's being multiplied here. But we'll see that in a moment. So let's simplify. So we get 4 squared, and we know that 4 squared is 16. And then 2 squared will be 4, plus 3 squared is 9, minus 2 times 2 times 3. 2 times 2 is 4, times 3 more is 12. And we get cosine of X. Okay? Well, good. Well, from this point, we can simplify this a little further, and we get 16 equals 13 minus 12 cosine X. Now, the most common mistake that's made here is that people will say, oh, 13 minus 12 is 1, and then we could just do inverse cosine. No. Order of operations says that you would multiply before you subtract it here. So in order for us to solve for this, we would do the inverse of that. So before doing a subtraction, before multiplying, we're going to get rid of the subtraction. So to get rid of the subtraction, we would have to move the 13 to the other side. And so if we did that, we would end up seeing that if we subtract 13 on both sides, we will end up with 3 equals negative 12 cosine of X. Okay, 13 minus 13 would become 0. 16 minus 13 would be 3. Right. Now we can divide by that negative 12. So we divide both sides by negative 12. We end up with cosine of X equaling 3 over negative 12, or negative 1/4. Okay? Well, have you ever had to solve for X before, or if I solve for an angle inside of a cosine function? Yes, you have. Well, how exactly did we do that? We use the inverse cosine. To get rid of cosine, use the inverse cosine. So we would do inverse cosine of negative 1/4, and that would be our missing angle. So let's see what we get when we do that. When we take the inverse cosine of negative 1 divided by 4. And so what we end up getting here is that angle X is approximately 104.48 degrees. Well, so that means this is an obtuse triangle. Doesn't look like an obtuse triangle. That's okay. This was not drawn to scale. We just knew the three sides were 2, 4, and 3. We didn't know if it was obtuse, if it was acute, or what. But now we know for certain that this is an obtuse triangle, and the side opposite of 4 is the obtuse angle, which makes sense because that's the largest side. Okay, so we know that x is 104.48. So I'm going to save that piece of information up here. All right. Well, let's use the law of cosine again to find another side. Well, this time let's find b, just because. We could solve for a instead, but I'm going to solve for b. So if you need to pause now, you can. All right, so we'll continue from here. So we're going to set up law of cosines, but this time we're going to be looking for angle b. So I'm going to erase this information. All right, so let's get to setting up the law of cosines so we can find b. Now, b is opposite of side 2. Okay, so that means we would have 2 squared equals, we're going to use these two sides because they make b. They form the angle b. So 3 squared plus 4 squared minus 2 times those two, 3, 4, cosine of b, because it's the angle we're looking for. Okay, so again, law of cosines to set it up. The side that's opposite of b is 2, so we get 2 squared equals the other two sides squared minus 2 times those sides, cosine of the angle we're looking for. Okay, all right. So as I said before, you could set this up to move this over and then divide by this, or you can simplify it first. I think, as I said before, most people it's easier to simplify it first, so we'll do it that way. So 2 squared will give us 4. 3 squared will give us 9. 4 squared will give us 16. 2 times 3 is 6. 6 times 4 is 24. Cosine of b. All right. So we simplify this. We get 4 equals 9 plus 16. 9 plus 16 is 25. Minus 24 cosine of b. Again, the most common mistake is subtracting these two. Do not do that. Order of operations says you would multiply before you subtract. So do not subtract those two. All right. So how would I solve or get cosine of b by itself? Well, we know from solving complex algebraic equations that we would need to move the 25 to the other side first. And to do that, we would do the opposite of it. So it's positive here, and it's subtracting this. So to get rid of that, to make it become 0, we would subtract 25. 25 minus 25 would be 0, right? So we need to do the same thing on the other side. 4 minus 25 will give us a negative 21. And so we get negative 21 equals negative 24 cosine of b. And from there, how would you solve for cosine of b or get it by itself? That's right, we would divide by negative 24. Okay, and so when we do that, negative 21 divided by negative 24, we can reduce that because both of these are divisible by 3, and we would be left with 7/8. So we would get 7/8 equals cosine of b. So 7/8 equals cosine of b. Well, got a little bigger there. 7/8. So in order to solve for b, we would need to get rid of the cosine. To get rid of cosine, we have to do the inverse cosine, like we did when we were looking for the angles. Anytime you're looking for an angle, do the inverse. Every single time you're looking for an angle, do the inverse. So we're going to do the inverse of cosine. So we end up with cosine inverse of 7/8 equals b. So let's see what we get when we do that. So inverse cosine of 7/8, we end up seeing that for angle B, we get 28.96 degrees for angle B. 28.96 degrees. All right. So if you need to pause the video, you can here. Okay. So knowing that X is 104.48, that B is 28.96, how could we find A? Yes, there are two ways for us to do this. Honestly, there's three ways that you could do this. We could use law of sines to find out what angle A is, because we already have these two angles, and we have all the sides. We could set up a relationship between A and 3, and 2 and B, or X and 4, using law of sines. We also can use law of cosines again. We've already demonstrated that if you're given three sides, you can find any of the angles within a triangle using law of cosines. But there's also something that we learned quite a while ago. We learned that if you take the three angles in a triangle and add them all up, they have to equal 180 degrees. And because we know that, when I take 104.48 and add 28.96, and I subtract it from 180, I will know what angle A is. So 180 minus 104.48 minus 28.96, we end up with that angle A is going to be 46.56 degrees. And I challenge you to go use law of cosines to see if you get the same thing. All right, so the two most important parts for using law of cosines to find the angles, first you have to be given all three sides, of course, is to, how do I set this up? How do I set up law of cosines? Well, I know what angle I'm looking for. The side that's opposite of it will go onto the other side of the equals. Everything else can just be substituted in as normal. Make sure you do not subtract these numbers here when you get to this step. Again, that is the most common mistake, and many people get the wrong angle because of that, or they get an error when they try to find it. All right, that's using law of cosines to find the angles of a triangle given all three sides. You have to be given all three sides in order to do this. So I will see you soon.